Okay, Assalamu alaikum, dear students. Um, this is week number 8, and we are going to discuss the conditional probability. We have discussed the same concepts in our face-to-face classes when university was open. So I'm revising it, and I think we will be reaching towards Bayes theorem up to our midterm examination. Inshallah, during the interactive session, I will guide you guys regarding the strategy and marks distribution and your papers in our interactive session. So, what is basically the conditional probability? Up till now, we were talking about the frequentist methods in which you can find the probability of any event. Let's say you have any event A, and you want to find the probability of A. That was basically equal to the number of elements in set A divided by the total number of elements in the sample space. This is one of the most important formula in any frequentist method, in which you have to find the probability by the frequency of any element. If the frequency of any element is higher, the probability or the chance of the occurrence of that element will be higher. But what is basically the conditional probability? In conditional probability, you have basically two events. One event has been occurred, and you want to find out the chance that what is the chance or what is the probability of the happening of another event. Okay, so let's say you have two events, event A and event B. Okay, so let's say event B has occurred. So with the occurrence of the event B, what is the chance of the occurrence of event A? Okay, so this can be calculated by conditional probability. So how can you find it? You can find the probability of A given that B has been occurred. Anything at the right side here, this is a right side, anything available here will be the event which has already been occurred. Okay, so for finding the probability of this event, we should have a formula which is this one. This is the formula in which you want to find out the probability of A such that the probability of B has such that event B has been occurred. This slash sign, this sign is the indication of such that. You can call it such that the event B has occurred. So this is equal to the joint probability of A and B divided by the probability of the event which has already been occurred, and the condition of this is that the probability of B should be greater than 0. If the probability of B is equal to 0, then then anything divided by 0 will be infinity, and this probability will not be you will not be able to find this probability. Okay, so if you consider an event B that has occurred, if the occurrence of B alters the likelihood of another event. Okay, so here what is the condition that the event B has occurred and the occurrence of B has changed the likelihood of the occurrence of A. Then you can find the conditional probability of A, which I have told you guys, and that is this one. You can find the probability of A given B rather than simply the probability of A, this one. Okay, you will not only find the probability of A, but now the condition is that another event B has occurred which is connected with this one. There are many examples, and we will discuss those examples. These two events are interconnected. Okay, that's why you can not only just find this probability, but this one. Okay, just like what is the probability of your employment? What is the probability of your employment or getting job? Okay, what is the probability of you getting job such that you have already done engineering? Okay, so now you can see that both the events are interconnected. If you have done engineering, then there is a chance of getting job. Okay, there's very high chance of getting job. But if you haven't done it, you cannot get a job. So there is a relation between these two things, and that's why one has occurred, and there, if one has occurred, you can find the probability of the other event as well. There are many other things related to this engineering, like what is the probability of you to build your own house after getting done your engineering? What is the probability of going abroad after doing your engineering? What is the probability of going for higher studies after doing your BSc engineering, and so on? There are many examples available here which you can quote here for finding the conditional probability, or for giving example of the probability, conditional probability. But the another example here, which you guys will be already familiar, and that is related to the cricket. Okay, let A be the event that Pakistan win a test match against Australia. Okay, A is another event. A is the event that Pakistan will win. Pakistan will win. Actually, I have been writing all these things with the touchpad. That's why there are some minor issues. I'm trying to get addicted with this thing, and inshallah, someday these things will be written correctly. But till then, you have to bear with me. Okay. Let A be the event that Pakistan wins the test match against Australia, and let B the event that Pakistan wins the toss. Okay. What is B? B is that Pakistan win the toss. Toss winning. Okay. So let's say Pakistan and Australia has been playing, and A is the event that Pakistan will win, and B is the event that Pakistan has already won the toss. So you have to find the probability of A given B. Okay, it will be written like probability of, again same thing, probability of A such that B has already been occurred. Pakistan has won the toss. So what is the probability that Pakistan will win this test match? This is what this thing is telling you. This formula is telling you that has already been occurred. Okay, they have tossed a coin, and Pakistan have won the toss. And after winning the toss, what is the chance of winning this test match? So this is again a case of conditional probability. How can you find it? You can find it by the formula, which is P intersection B. What is P intersection B? That is called the joint probability. Okay, this thing is called the joint probability. Joint This is a joint probability, and the denominator term is a marginal probability. These are basically two terms. marginal probability. So you have to find the joint probability and marginal probability. What is the joint probability? That would be intersection. Wherever intersection comes, it means and. Okay, union means or, intersection means and. Just like I have told you guys in DLD that AND gate is always used as an alternate of the multiplication in digital logic, and OR gate is used as an alternate of addition in digital logic or in Boolean algebra. Similarly, in set theory, intersection is used as intersection is used as an alternate of multiplication, and union is used as an intersection of union is used as an alternate of the addition. Okay, so here what does it mean? It means the probability of A and B, means what is the probability that the team which is playing here has previously won the task and also won the match as well. Okay, this is this thing. Similarly, what is probability of B? Probability of B means probability of winning the task. So what will be the chance of the winning probability here? The chance of winning probability will always be what? That would be half, because if there is a fair coin, then the probability of winning the toss will be the half. Okay, so now that can be calculated by P A intersection B. This is the joint probability divided by the probability of B. Okay, this thing is already known, but this thing is not known. If you see this thing, this one, this is the joint probability. Joint probability is not known here. How can you find out the joint probability? You can find the value of this joint probability from all the previous data, in the ground, in let's say the match has been going on in Australia. So all the previous record that how many teams have won the toss and also won the match over a specific pitch, or in specific conditions, like in Australia condition where the outfield is very fast. Similarly, if the match has been going on in Pakistan, so what is the chance of winning the toss and then winning the match as well? So you can find it by all the previous data. That's why in these typical questions, the previous data matters a lot. In weather predictions, conditional probability is used. In many other things like in movie recommendation systems, conditional probability or Bayes theorem is usually used. In many artificial intelligence cases, conditional probability is used. From the artificial intelligence thing, I have just this thing has just reminded me that I will share some couple of videos. Just take a look over those videos. Not related, not those videos will not be related to your course, but videos are very interesting and will increase your interest with the field of artificial intelligence, and you guys will get to know that this thing is, or this field is very extensive. It has been used in many fields, and you guys will love that videos. Okay, so I will upload those videos. Basically, those videos are available in YouTube, but you cannot find it. I will upload those videos and kindly take a look over those videos. Okay, I think the concept of conditional probability is now clear. The thing is this thing I have already discussed this thing in your face-to-face classes as well. So this was a repetition, and now I think it is more clear. This is a Venn diagram, and I have already discussed it by using a Venn diagram as well. Because when I have told you guys that once an event has been occurring, then the overall sample space will be changed. Okay, I have told you guys that the sample space then will be this one. This will be the number of elements in probability of B, or the number of elements in event B will be the sample space. And what do you want to find? You have to find the probability of A and B with the sample space of P. So that's why what you will get, the number of event elements in A intersection B divided by the number of elements in event B. Okay, I have proved it in your class, so I think there will be no problem with this thing. Let's move on. Okay, this is thing that let me raise out. How can you find the probability? So I have told you that in geometrical interpretation, this is basically, this thing is basically the geometric interpretation of this formula. Okay, in set 3 I have told you that the number of elements in any event divided by the total number of elements in sample space gives you the probability of that event. Okay, but in geometrical point of view you can find out the area of the event divided by the overall area of a sample space. This thing will also give you the probability of the event. So when you find out the probability, you will see that the probability of A will be equal to probability of B. In this case we have discussed these Venn diagrams in your class. This thing again. Okay, but you can see now here that from all these questions you can find the probability of A given B by this formula. This is probability that Pakistan will win the match given that they have won the toss is this one. Event B has already occurred. The event A will now only occur within the reduced sample space, which I have told you, because because now the overall sample space is this B, and you have to find the probability of this event under these circumstances. That's why the sample space has been reduced to B, and you have to find the probability of intersection B. That is the overall concept behind all these things. Okay, let's move on. Okay, this is the example which we have done in our class. Let me do it again. A ball is selected from an urn containing two black balls, number 1 and 2, and two white balls numbered 3 and 4. Okay, a basket or urn has two black balls over which the numbers 1 and 2 are printed, and two white balls over which the numbers 3 and 4 are printed. Okay, these are four balls in a basket. The number and color of the ball is noted. Assuming that the four outcomes are equally likely, find that probability of A such that B has occurred and probability of A such that C has occurred, where A, B, and C are the following events. The events has been written down here. A is the event that black ball is selected, B is the event that even number ball is selected, and C is the event that the number of balls selected is greater than 2. These are basically the three events. Okay, and this is example 2.4. So how would you guys approach this question? I have told you that there are different steps of finding the probability of any event. First of all, you have to understand the question. This thing is very important in probability. You have to understand the question to have a good approach. Okay, after it, you have to write all the things in a set form. If first of all, you have to write all the things in set forms, and initially, in first step, you will write the sample space. What is the sample space? What is the sample space here? Okay, you will have to write all the elements of a sample space. After it, what is the event A? What is event A? what is event B, and what is event C. Actually, what is event A, B, and C in terms of the set equation, in terms of sets. Okay, these are basically explained in words here, but you have to write all these things in the form of sets. So by writing in the form of sets, you will know that you will know the intersection or union between different elements. So here you have to find the probability of A such that B has occurred. So you will also need the A intersection B because of the formula of conditional probability. You will also need A intersection B. Okay. And you will how can you find it? If you have written all these things in the form of sets, then finding it will be very easy, because intersection means the common elements between the two sets, and union means the overall combination. Okay, you have to just write the combined set of the two sets, or the two events if union is given. If intersection is given, you will see the number of common elements, and you have to write all those elements here. Okay, similarly, the probability of A given C has been also asked to find, so that's why you will write A intersection C here as well. You have to find these things. This is the first step. Okay, then what is, after writing all these things in this way, what is the second what is basically the second step? You have to write the probability of different events. What is the probability of A? What is the probability of A? How can you find it? The number of elements, the number of elements in set A divided by the total number of elements in sample space. Okay, similarly, the probability of B, okay, the number of elements, we have already solved this question, but this is the repetition. And actually, what does it mean? What I am asking you to do is to revise the method, that how can we approach any probability question. Okay, these are the mechanism. And then similarly, probability of C. And then how can we find the value of probability of A intersection B? Probability of A intersection B, sorry, probability of A intersection B will be equal to the number of elements in A intersection B, the number of elements in the set A intersection B, which is here, you have already written it here, and divided by the number of elements in a sample space, and so on. Similarly, in uh, finding the probability of A intersection C, and similar approach will be used there. Okay, so let's move on. After finding all these things, you will write the formulas. You know the formula is this one, formula of this one, and the question will be quite easy there. Okay, let's move on. Okay, you guys can see that the same approach has been used here. First of all, they have written different elements, and then their corresponding sets, then probability of A intersection, their probabilities, and then after finding the probability, they have written this one. Or the second step, which is this one, they have skipped this one. But if you guys will not follow this step, it it has been done here, but because you will need probability of B, probability of C as has been done here. So first of all, find the probabilities of all the events, and that would be required in the later steps as has been needed here. Okay. So this is the question, and this you can see that all the steps which I have told you has been followed here. Okay, these are the steps. Probability of intersection v probability of a given b, you will need the probability of a and b, joint probability of a and b divided by the probability of b, which I told you to find earlier. Similarly, probability of a such that c has been occurred equal to probability of a and c divided by the probability of C. And after finding it, you will see that after doing all these steps, you will see that the question will become very easy. Okay. First thing you have to follow is that please don't panic. If you cannot understand a question, read it again, solve it solve it in your rough work, and then do it in the clean work. If you are not if you are not basically understanding the question, just follow the procedure which I have told you, and then you guys will know that the question will become very easy. Actually, these probability questions are somehow tricky sometimes, so you have to think over it. Basically, you can develop probabilistic thinking um, by practicing a lot. That's why I have told you guys to practice and practice all the examples and your exercise question, so it will be easy in your it will be easy in your exam to solve all the related questions. Okay. So in this video we have discussed the conditional probability. In the second video I will discuss the multiplication rule and many other things. So till then, Allah Hafiz.